Okay, today we will talk about, in general, learning algorithms. We have talked about a few. Feature extractor. We have talked about support vector machines. Now, we want to talk about learning algorithms in general, what are the categories that we have. And then at the end, I will tell you what else we will learn for the rest of the semester. Okay? Now, when we are talking about the learning algorithm, there are three main categories that people can talk about. Supervised learning, which you have heard it a lot while I was talking, is supervised learning, unsupervised learning, and reinforcement learning, which is much newer than among the other type of learnings. Now, if you remember, on one of the sessions that I was done here, and Pedro was here, he was talking about dividing the data set into the test and training and so on. Do you remember that? Good that you studied. And when we have the training, in other words, when we have some advanced information in our hand which we can use in order to do some tasks like labeling, then we always call it supervised learning. In the unsupervised learning, in opposite order, we don't know anything about it. So let's talk about them a little bit more in detail. So one question from me to you. What is supervised learning? What do you think supervised learning is, Ozan?
We know the input and output, and we are just making the system behave like inputs. When we give input, we want him to act like output, read output.
That's true. We already know the label data set. We can go and get all the information from this label data set. And after that, we can, when you give me a new input, based on this information, I'll tell you what the output is. In general, if you want to consider as a very general question and problem, it is something which we call it function approximation. I'll give you some data, and you can, what is the input, what is the output, as Ozan said, and by looking at that one, I'll try to tell you what the function is. And after that, I will guess what will be the new value for the function. So let's do something like this. I give you some pairs, and I want you to answer my question after that. And the pairs are these: 1 and 1, 2 and 4, 3 and 9, 4 and 16, 5 and 25, 6 and 36, 7 and 49. What is your observation? What do you think the function approximation will be? Output is input squared, right? This is what we can observe from this type of data. So, question. What do you think about, if this is true, what do you think for the input value 10, the output is? 100. 100 can be true if the function is y is equal to x2. But the question is that, is it really y is equal to x2? Imagine this scenario. Everything is a square except for number 10. Or everything is square up to number 10. In other words, we never know the actual value or the actual function. We try to approximate it. That's why it's called function approximation. We look at our data and we approximate. That is why it is very important to have very good selection of the data. You will see towards the end, we have one slide that we say that we need to worship the data. Wrong data will give us very bad information. Okay? Maybe it was only a very a specific type of data that I have selected and they were squared, and in the reality the function was totally something else. Okay? Now, what we are doing, what we want to do in general, in the supervised learning, we have some data, some example in our hand. By looking at this example, we are approximating our function, which can generalize the whole thing that we have in our hand. In other words, I can use some phases of yours, and I make my system to work to say that, okay, this is Fatima, this is Aygul, and so on. And then I will say that now I have tested here, so here is the system I am selling it to you. So I try to generalize my algorithm. But this is the biggest problem that we have in machine learning. What is the biggest problem?
Generalization.
Generalization is the biggest problem that we have in machine learning. What we do, we start from example and we go to a general method. Do you know in mathematics what it is called? From an example, we go to a general method. Have you heard of the inductive methods? You will start from some example and you go and start to do some generalization. So what we have here, things are very biased, or we call it inductive bias. Bias, when we say that something is biased, it means that you should have some information about it beforehand. Like before you come and meet me, they tell you that, oh, Shahab is I don't know, he loves food. So when you come to me, you have this opinion that if you have a sandwich in your hand, you need to share it with me. Because you know that Shahab loves food, right? But imagine you absolutely have no idea about me, and you come to me with, let's say, a bag of candy. So you don't know that you need to share the candy with me, because you don't know anything about me. Now what happens is supervised learning, we make the thing biased. We have some information in our hand, and accordingly we approximate our function. Now, what is the opposite of the induction? Is deduction. So in general, in supervised learning, what we do, we start from an example and we go to a general rule. In other words, from a specific, we go to generalities. And this is not always good. Most of the time, it's not good. While in the deduction, what do we do in the deduction? This is the opposite of induction. So what we do, we have the solid rules. We know everything, and from this solid theorem, solid rules, we go and we make some examples. So what we do, we have the general rule, and from here we go to get some specific instance. I tell you that, Eric, why didn't you do this yesterday? And he says that because of something. So this because of something means that there exist some rules, and as a consequence of this rule that I have an exam, I didn't do that. In other words, all the reasoning that we do is actually deduction. We are making a reason based on some rules that we have in our hand. Now, all the logic programs that we do is also this deductive reasoning. In other words, there are some rules and we are trying to extract things from this reasoning. Now, let's do an example. Let's do an example, and the example is this. Assume we have a rule, and this is the most fundamental rule in the whole world, and it says this. A implies B. Okay? A implies B. So when I tell you A, what else do you know? B. Because you know that A implies B. Like, let's put it in an example which you understand. Getting 0 in the exam means you fail. So if you get 0 in your exam, what do you understand? You fail, right? A, I hope all of you will get A. But, so if I tell you A, because A implies B, you know that B also is happening. So this is called deduction, which is the opposite of induction. The first example that we did, I gave you some example, and you try to find out what is the function. It was an example of induction. So they're going in the opposite order. Induction also can be like this in the daily life. Did the sun rise yesterday? We're not talking about Estonia. Let's go to the South Europe. Did the sun rise in yesterday morning? Yes. Did it happen the day before? Yes. Did it happen the day before and before? Yes. And then the next question is that as in the last 10,000, 20,000 years, the sun rise till now. Will the sun rise tomorrow? This is a philosophical question, right? Will the sun rise tomorrow? Based on induction, we are hoping that yes, it will rise tomorrow. Otherwise, whatever you believe it, but I mean, we assume that it goes through. So in induction, we hope the data that we have is very good, very well behaved. So the function that we are trying to approximate will be a good function which you can trust based on its results. If the data is a bad data, the function will be a bad function. The decision that we make based on that function will be a bad decision. So, these are all the things that I said. So at the end of the day, supervised learning is the function approximation, which very well depends on the input that we are providing. If it is a good data, if it is a good example, then the function will be a good function. The result that we will get will be a good result. So another question of mine to you: what is unsupervised learning? Suma, what is unsupervised learning?
The data are not labeled, so the system cannot get reward or penalty feedback after the processing.
Yeah, in general, in the supervised learning, we gave you the input and output at the same time. In other words, you have some example in your hand. Here in unsupervised learning, we don't have examples. There is no examples. And you have something in your hand which we call it input or data or whatever you want to call it. We look at these inputs and we try to extract, we try to drive some information or some structure from this data that we have, this input that you have in your hand. And we are looking at to find some relation between these ones in order to help us, let's say, do some clustering. Now, let's do an example, and the example will be something like this. Imagine you want to learn about animals. This is actually a real-life example, not for your age, hopefully, but for kids. And they want to learn about animals. As a human being, we want to learn animal, and you are seeing lots of pictures of animals. So you can say all these categories of animals are called dogs because they have 4 legs. So you call them dogs because they have 4 legs. So you make some observation, you look at them, and you see that because they have 4 legs, I call them dog. Apparently they can be, let's say, cats. They can be, elephant, horses. But it cannot be tree, because tree does not have 4 legs. The other ones have 4 legs, so you categorize them as dog. Okay, this is called unsupervised learning. Why? Because no one is teaching you anything. No one is telling you that, no, this is the condition that you have to define. So you are categorizing it based on whatever you like to. Okay? So as you can see in this example, you can call whatever is a 4-leg a dog, and if it doesn't have 4 legs, you do not call it a dog. You can call it whatever you want to. So there is no label in advance. Supervised learning, we said it is function approximation. You have input, you have output, you look at them, you try to find out the function, which for the input gives you those output. So if I give you a new input, you can estimate what is the output. But unsupervised learning is actually giving you a description. I gave you all the animals, and then you look at it and you say, okay, 4 legs, it's dog. So you are making a description. You are looking for legs. If they are 4 legs, so you categorize it as dog. If it is not 4 legs, if it is 2 legs, you categorize it as human, even if it is a kangaroo. So when we are talking about description, some people come and actually say that unsupervised learning is basically summarizing what you have. In other words, dogs are those things which has 4 legs, even if it is a horse. We call it dog because it has 4 legs. So we are making some summary of that one. In other words, we make a shorter description out of the data that we have. Keep it in your mind. Still, we don't know anything. There is no label. We do it based on what we observe. Now, in order to have a better understanding of unsupervised learning, let's imagine that you have this image. So you have lots of pixels. And basically you look at those pixels and then you say that if within this pixel, I have pixel which looks like this, I'll call it a human. Or I'll call it a male. Or I'll call it a female. Or I'll call it whatever you want to. And in line with this, imagine that you go to the crowd and you look at the people outside, like hundreds of thousands of them, and then the question is that, please cluster them. Everything is in your hand. You are outside and you need to cluster them. So what you do, you can say that, oh, okay, I look at the hair of the people and say that those who are blonde and those who are not blonde. Those who are bald, those who have curly hairs. Those who are male, those who are female. It's up to you. But what happens at the end as an output, what you give, I tell you that go and cluster those people. You come to me and you say that there are 25 males and there are 40 females. Okay? Or you come to me and you say that there have been 10 people with beard and 70 people without beard. Or you come and say that the majority of the people were wearing raincoat. So you come with some description to me, then I'm telling you that go and cluster them. And one very important thing is when we do it, everyone, this is a conditional example, everything that you do are correct. In other words, if you want to label or come with a description to say that they are male or female, or then someone else says that, oh, they are blonde or not blonde, they are all equal with each other. We don't say that something is more prior than the other thing. If you want to say that something is more prior than other thing, it means that we are going into the supervised learning. In the unsupervised learning, we do not have any signal in advance. You don't know anything. So everything that we do will be equal to each other. Do you know those functions, those values that in the supervised learning I provide you, you know it in advance, or those signals that you know what it's being called? The information that you have in advance and you approximate your function is called
training set.
Training set. Now, unsupervised learning gives me some summary, some description, right? And supervised learning tells me the labels based on all the values or all the things that I have in advance. So this is pretty cool because it tells me that I can use unsupervised learning somehow in the supervised setting. In other words, I can have a very nice description of my data, okay? And I can use this nice description in order to have a better approximation of the function. Rather than, in other words, I can have an image like this. Instead of having a pixel into my supervised learning and approximating the labels, I can do this. I can have the pixels, I can have some unsupervised learning which produce some summaries, some short description. And now those summaries and short description can be used in order to make labels by using the supervised learning. So, and in the reality this happens. We prefer to have the combination of all of those ones. If you remember in the homework 2, which I'm sure that, homework 3, which I'm sure that you have started to do it, I said we want to use super vector machine, okay? And I told you that whatever you want to have as your input features is up to you. Go and choose it by your own. Use the pixels. I remember Kevin said, can I use all the pixels as a feature? And you said yes. Or you can go and use, let's say, ICA and do the clustering and then use those features. So you see that you can have the combination of these two together in order to make the labeling. So instead of having a pixel as an input of supervised learning to get the labels, you can introduce them intermediate session. Now, the process of unsupervised learning is actually something which is called density estimation. Do you know what is density estimation? I give you lots of random variables, you look at them and you estimate what is the probability distribution function. So this is the whole process will look like doing something like that. And we will talk about this one a bit later when we are talking about using the probability distribution function, using the probability modeling in order to see which class we belong to. You remember, I think it was Eric who asked, when we are here in the SVM, can we use probability to guess what is in this region? I think it was you who said this is a no-man region, and I said yes, then it will not be SVM, we have to add some probability into it. Now, we can see that probability is everywhere. So in the learning, we really have probability. Approximated function means it's not really the function, so there is a probability of being wrong or right in there. Now, as we notice, as we are going further, we start to see probability and the statistics playing a very important role. And of course, we started from the statistic, and it's very natural we continue to root through the statistics because we have lots of data. You look at these data in order to make some decision. Now, the third method of learning is reinforcement learning. This is what we do. By what we do means that we as humans, this is what we do. Now, it means that how can we learn better through the experience? In other words, you do some action and you want to do it tomorrow again so you can do it better because you know that what you did was not correct maybe today, so you try to enhance it more and more. In other words, as a human, we never get to a constant situation. Every day and every time, even if you do it repetitively, we try to become better and better. Now, this is what we want to have in our robot. This is what we want to have in our AI machine. That every day that it does this task, it will learn further and do it better. It plays chess with you, it loses the game, so it learns. So next time it will have a better approach. So this is something which is very important. We try to do it quite a lot. Now, one thing about the reinforcement learning is that usually people often describe it as learning through a delay of art. In other words, we don't get the feedback instantly. Something happens, we make a decision, everything is finished, Eric, and then we will get back and see that, okay, we have done something right or we have done something very wrong. So the feedback in the reinforcement learning comes much after when the decision has been made. In the supervised learning, it is very cool because before we do, it tells us what we do, how we have to do it. Already we know. It should be S squared, so I exactly know what I have to do in order to get the output. In the unsupervised learning, I do it and I get a feedback back and I continue in order to enhance it more. But in the reinforcement learning is different. Now we can do an example. Do you know the tic-tac-toe? In the tic-tac-toe game, I used to be a champion, so I know it very well. So what we do is this. I press and put an X in here, and you put an O in here, okay? I put an X in here, you put an O in here, and then I put an X in here, and I tell you that I won. So, and you will realize, oh, okay, you lost. So, reinforcement learning is like this. You don't know anything. You play. Then I tell you that X won. And then you get back and say that, okay, X did this and won. So why did I do wrong? So you get back and you start to think, what was your approach that it was wrong, and you try to enhance it. Next, it doesn't mean that next time that you do it, you will win. But next time, even if you lose, you will try to investigate why you lost and why the other person wins, so you can learn more and more and more. So if you play, let's say, 100 times, then you can maybe win. Even, maybe you lose, but maybe this is the structure of the game. This is what it meant to be. So what happens within several iterations, you start to learn more and more. Do you know how we do it in our daily life? We said that we do it all the time in the previous slide. It's like this. I tell you that, okay, come, let's play this game. And usually what we say, oh, I don't know it. And then they say, don't worry, just come and sit by me and you learn. So what it happens, you actually have no idea of the game. You sit by the person and you see how he is playing. So whatever he or she is playing, you assume this is the rule. Then in the next iteration, you see that, that was an exception. The rule is something else. So you are developing and you are learning the rule. Well, learning the rule is not made possible with the reinforcement learning. But as soon as you know the rule, but you don't know who is winning or who is losing, or how to win or how to lose. So we learn it through lots and lots of iteration. There are lots of AI games which you can play, tic-tac-toe or chess or I don't know, poker or whatever the games are, and they are using this type of learning. Now, go to the next slide. So we understand that reinforcement learning is very difficult. Because, why is it difficult? You have no idea. And I tell you that you have to do it. And you don't know what you need to do it, but you have to do it. You know, it's quite common in the world of research. When you go to your supervisor, he expects you to do something, and you don't know what you need to do, but you know that you need to do something. So this is the reinforcement learning. You do it, and you see that, okay, he smiles, then it means, okay, that you are doing it right, and next day you do the same thing, and he goes crazy, so you understand you shouldn't do it for the second time. So you are learning what you are proceeding in. It happens as a human, we learn like that, right? The kids do something, I don't know, make a very stupid noise from the mouse, people laugh, so he thinks, okay, this is correct. Do it for the second time, people will not laugh. So we continue doing it again, and we see that people goes very angry, and we understand that making that noise was not really cool. It might be cute for the first time, but further it will not be very nice. So this is how we are learning, right? So we are getting it through a loop. So as I said, it's like playing a game without knowing the rules, without knowing that how you can win and how you can lose. Now, imagine I am teaching you what is a supervised learning, what is a non-supervised learning. And we look at the techniques, like let's say, I'm going to teach you the decision tree, and I tell you that this is a supervised learning. And then when you come to the practice to do it, you find that really it's not supervised learning. Or I'm teaching you a technique and tell you that this technique is unsupervised learning, and you come into the reality and you see that really it is not unsupervised learning. So all the learning algorithms in the reality are something in between. Imagine the unsupervised learning, right? You go to the crowd and you divide them based on the sex, male and female, or based on the hairstyle. It means you have some assumption, right? You want to divide them based on the sex. You say that males and females. So essentially that you have an assumption, and if you have an assumption, it means that it is kind of a supervised learning. So you understand that there is something always in between. So you don't really have something which is solidly unsupervised or solidly supervised. Now, but one thing which is for sure is this. All the problem is an optimization problem. So no matter if we have supervised learning, unsupervised learning, or reinforcement learning, we try to optimize something. So the question is that what do we want to optimize in each of them? Now, in the supervised learning, we said it's called function approximation, right? So we try to optimize a function which score the best. In other words, it can approximate all my data very well. Right? So the aim is that to make the error as small as is possible. The example that I showed you was a very, very nice example, which you could easily see that it does the S-score. In the reality, what happens, you say that it seems that it squared the numbers. Imagine if you have the data like this. 1 and 1, 2 and 4, 3 and 8, 4 and 16, 5 and 25, 6 and 37, Now I'm going to tell you that, can you tell me that what is the function? It seems to be S squared with a very small error. The best function that you can fit in here, and it gives you the minimum error, is, let's say again, y is equal to x squared. Although we have a small failure in these two, but so if I tell you that what is the value for 7, in Python we say it's 49. And we understand that there is a small range of error, right? So we try to minimize this error. In other words, in the supervised learning, we try to optimize the function which is scored for us. In unsupervised learning, what we do, we try to have a system which do the clustering, and we want to make this clustering as good as it is possible. In other words, let's say they can be discriminative well enough, they can be descriptive well enough. So if I look at this data and one of the features that I did is legs, so I understand that I am not talking about balls or I don't know, the baskets or I don't know, breads, because none of them have legs, right? So it has to be very good discriminative. So in unsupervised learning, we try to optimize the clusters which scores very well. And in reinforcement, we try to optimize the behavior which scores the best, because we learn in reinforcement through the behavior. Now, and as I said, in all cases, yes?
For example, that example,
Yeah.
does the supervised learning also have exceptions? For example, it finds that it's generally y equals x squared, but if the value is 3, then it's, for example, x squared minus 1, and if it's 6, then it's...
That's very good. Yeah, I understand. What Eric says is this. Can I say, based on his algorithm, y is equal to x squared if x is not 3 and 7 or 6, if x is equal to 3, it is 7, if x is equal to 6, it is 37. So, right? Say.
x squared plus 1 and minus 1.
Yeah, okay. Let's say it is x squared plus 1, this is x squared minus 1, what's the result? Can I write it like that? Absolutely okay. Now, my question. What is the value for 7? You see, you are training for the known data.
Yeah.
But you want to guess for the data which is not in the database. If it was in the database, I would never ask you, I look at the table, exact value.
Well, extrapolation is always hard.
Yeah, this is the whole idea. That's why we call it function approximation. Because our function will approximate for next values. It's out of the data. The data already is there. Right? If imagine I have a face recognition system and I have the photo of you like this and it's in the database. If you come as you are, I know that you are who you are. The problem is that if you come with the sunglasses, do I still recognize you? If you come with a beard, do I still know you? Because you are not now in the database. I am trying to approximate. I'm trying to say that, okay, it seems to be Eric or not. Now, as I said in the supervised learning, unsupervised learning, because you have to observe. So if, imagine you go to the crowd in this weather and it's foggy, which you cannot see them 1 meter, you really cannot categorize people, can you? You don't see anyone. So data is very, very important. As it's known that data is the king of machine learning. Bad data, you will get bad results. It doesn't matter what is the method that you use. Good data always take you to the glory. So we have to be careful about the data. Now, from computationalist point of view, do you know who is we have computer scientists and we have computationalists. Do you know what the difference between them? Computer scientists, Levy too, they work on algorithms. Algorithm is the center. So I have this algorithm, go and fix your data. The people who work as a computationalist, they say that, okay, data is important. I look at the data and I drive algorithm out of this data, the algorithm which fits with this data. And in general, in machine learning, we have the data. It's like that. I do the face recognition, right? I cannot say that, please put out people with darker skin, put out people who are bald, put out who are female, then why do I need your algorithm? You understand? So we have to accept the data and drive something out of this data. Now, from computationalist point of view, data is playing a very important thing. Data is the central of everything. So what happens is that we have to look at the data and extract some algorithm out of this one. And the algorithm should be in a way that will let us to predict the next data better. I don't care that how this formulated. You can use supervised learning, unsupervised learning, reinforcement, but what we want to do, the question is that what will happen if I give you the value of the input of 7? What is the output? I don't have it in my database, right? Or you look at the people outside, thousands of people, and you categorize them. The question is that if suddenly the door opens and someone that you have never seen comes, do you put it in first cluster or second cluster or third cluster? Right? So this is how you do. I am teaching you that this is winning, that is winning, you are observing, and then if you come and you play with someone else, you totally different activities, whether you are winning or not. You know the Kasparov who won against the Deep Blue playing chess? It was the reinforcement learning, and although it knew lots of algorithms, still it lost because it's learning. You know, it doesn't mean that after 100 times of learning you do the best. You may still fail, but you do learn. Now, so we understand what are the supervised, unsupervised reinforcement learning. We will talk about 3 main things till the end of the semester, but each of them that have lots of things split inside. So based on what is the time constraint, we can go as fast as we can. One of them is, the first thing that we will talk is the decision tree. It's a supervised learning. It's very important. It's easy to implement. And one of the reasons that we talk about it is, no matter later what you do, you can always combine it with this decision tree. Okay? The next thing is regression and function approximation. Is it supervised or unsupervised learning? Supervised learning is a functional approximation. It's the synonym for supervised learning. So again, we will try to see how we can do that one. We will talk about it, and then we go and talk about the ensemble learning boosting. And here you can see thousands exaggeration, tens and hundreds of methods. We will try with some basic methods, and we try to go as far as we can go till the end of the semester. Do you have any questions? If you have no question, this is the end of lecture for today.